Today we're going to talk about a review of Math 2. We're going to look at factoring greatest common factors and factoring trinomials. So when we're factoring, remember the first step is to always factor out the greatest common factor if possible. And step 2, you look to see how many terms are there when the equation is in standard form. So if there are 2 terms, a binomial, we look for patterns, and we're going to talk about that later. When we get to Unit 3. And if we have 3 terms, a trinomial, then we're going to look to see if the leading coefficient's 1 and find factors of the last term that add up to the middle term. And if the leading coefficient is not 1, we're going to factor using slide and divide method or factor by grouping, since that's what we learned last year in Math 2. So first, let's go ahead and talk about finding the greatest common factor between 2 numbers, and then we'll look at it for our polynomial equations. So when you're looking for your greatest common factor, you're looking for the largest number that can be divided by both numbers. So if I want factors of 15 to factor this down, I know that 3 times 5 is 15, and those are both prime numbers, so those don't factor anymore. And 25, we know we can break down into 5 times 5. So if we look at this, because they both share a 5, that means that our greatest common factor would be 5. Looking at the next one, we have 40. So we want factors of 40. So 40 breaks down into 4 times 10. And of course, we can keep going. So 4 breaks down into 2 times 2. 10 breaks down into 2 times 5, so that would be what we call the prime factorization, since we can't factor 2 or 5 any further. And then we're going to break down 44. So 44 breaks down into 4 and 11. 4 breaks down into 2 times 2. 11 doesn't break down anymore. So now we're going to look for our greatest common factor. So we can see that there's a 2 here, and we also have another one. And then that looks like that is it, because 2, 5, and 11 aren't the same. So if we have 2 times 2, that means then our greatest common factor would be 2 times 2, which is equal to 4. Now, could you have not factored all the way to see that it was 4 for the greatest common factor? Sure. So let's say that when we broke down the numbers, we saw right away, well, I know 40 is 4 times 10, and 44 is 4 and 11. Then I could have said, oh, those are in common, so my greatest common factor is 4. So you could also do that. There's usually a couple different ways we can make our factor trees. So looking at the next one, number 3, 4 breaks down into 2 times 2, and then 25 breaks down into 5 times 5. So notice there are no common factors here, so that means that really we would just say our greatest common factor is 1, because really there's none. So nothing actually comes out of this. Looking at the next one, we have 24 and 36. So if I find factors of 24, 24 breaks down into 2 and 12. And I can break down 12 into 2 times 6. And 6 breaks down into 2 times 3. So looking at 36, 36 we know is 6 times 6. And that breaks down into 2 times 3 and 2 times 3. So if we look for our common factors, we have the 2 here and here. We also have this 2 and this 2, and then I see a 3 and a 3. So that means my greatest common factor would be 2 times 2 times 3, which is, of course, 12. So looking at the next one, now we have 150 and 90. Let's say you have a hard time finding factors of numbers. You could always use your calculator and see that these are both even, so you know the smallest number would go into it would be 2. You could also see that both of these are ending in 0, so they're divisible by 5. So whatever helps you to factor, and of course, just because I factor something one way doesn't mean there's not other ways to factor this. So 150 I know is divisible by 5, 5 and 30. And then I know that 30 is 3 and 10 breaks down into 2 and 5. And if I do the next one, 90, so factors of 90, we could use again, let's do 3 and 30. So if I would have done 5 and 30 and 3 and 30, then I would have noticed the 30s in common. So I already know my greatest common factor is going to be 30. But let's say we did not see that. We're going to break this down. So this would be 3 and 10 and 2 and 5. So then we would see 2 and 2 and then 5 and 5. 3 and 3. And notice that I wouldn't highlight the 30 because those were already broken down. So again, that's where we get our greatest common factor of, so it's going to be 2 times 3 times 5, which of course is 30. So we're going to use this to help us with our factoring of our polynomials. So we're going to practice factoring out the greatest common factor. Looking at this first one, now we don't have any numbers here, but we do have variables. So if it helps you to write it all out to see what the greatest common factor is, that would be good. So a cubed is the same thing as a times a times a, 3 a's. And then of course we had the b minus a, and then b squared would be b times b. So if we're looking for common factors, we have a and also a b. So that means my greatest common factor would be a b. So when you find your greatest common factor, you're going to divide each term by the greatest common factor because that's how you get it out. So we're really dividing out a, b by each term. And if you recall, we talked about the rules and properties of exponents. So when I am dividing something with the same base, we subtract the exponents. So if here we have a cubed over a, remember that's a to the 3 minus 1, which gives us a squared. So this would become a squared. And notice if we have b over b, those cancel out. So that gives me 1, so we don't need to write 1. Minus a over a also cancels out, and b squared over b becomes minus b. So then the only other step we have to do is put the GCF in front. So a b times a squared minus b would be my factorization. And we could check our work. So if I have ab times a squared minus b, I can check by distributing ab times a squared. You remember when you multiply, you only multiply with this. If you have something being multiplied with the same base, you add the exponent, so that would give you a cubed b. And then now if we multiply this by the second term, negative b, that gives us minus a, and b times b would be b squared. So notice that gives us what we had originally started off with. So it's just easy way to check our work. So let's go ahead and look at number 7. Now we have some numbers in here, so we're going to look for the greatest common factor. So 5 is already prime, and 15 breaks down into 5 times 3. So I know that the number is going to be 5. So I know my GCF has to have a 5. And then if I look at my x's, if it helps you to write them out, we have x times x here and 1x here. This would just be y. So we have 5xxy minus 15 xy times y times y times z. So then you can see we have an x here and here, a common y, and that's it. So that means my greatest common factor would be 5xy. So I'm going to erase this because the next step that I'm doing is I'm dividing each term by 5xy. So the greatest common factor goes on the outside. And then when we divide, 5 over 5 is just 1, so that goes away. X squared over x is x. Y over y goes away as well. Minus 15 negative divided by 5 gives us negative 3, so that's why that's the minus still there. X over x is just 1, so that cancels out. Y cubed over y would be y squared, and z. So this gives us our factorization. So why don't you pause the video and see if you can do the next one on your own, and then when you're done, you can unpause to check your work. So if I look at this next one, I see I have 50, 10, 120, and -10. So I know that 10 can go into 50 and 120. So I know that my greatest common factor has to have a 10 in it. Could you factor it out like we did above up here to see? That's fine. It just would take you a little bit longer, but you can. And then if I look at my variables, this time I'm not going to write them out. So I have an m squared, 1m here, 2m's here, and 1 here. So at most I can only take 1 out because I only have 1 in common. Then I have n to the 4th, n cubed, n squared, and n. So that means my greatest common factor is 10m times n. So I'm taking out 10 mn from each term. So when I do that, I get 10 times m times n on the outside. So 50 divided by 10 for this first term is 5. If I have m squared over m, that becomes m. N to the 4th over n becomes n cubed. 10 negative divided by 10 would just leave me with a -1 placeholder. Do you really need to write the 1? No, but we're going to just leave it there for now. M over m is going to cancel out. N cubed over n is n squared. Then we have 120 divided by 10, which is 12. So plus 12, because it's positive. M squared over m would give me 1m, and n squared over n gives me 1n. And again, you're just subtracting the exponents. So 2 minus 1 is 1. So over here, -10 divided by 10 gives me a -1 as a placeholder. You don't have to write the 1, but we're going to leave it there for right now. Because if you'll notice, m over m would be 1 minus 1, which is 0. Anything to 0 power is 1. Because if we did the exponents, I'm showing you why it gives you 1, because it's m to the 0 power, which is just 1. So those cancel out and those cancel out. So here we do need to make sure we have that placeholder because there's no variables. So this would be my final answer. So that's factoring out the greatest common factor. So just going back to the steps. So step 1 is factor out the greatest common factor. Then we're going to look for how many terms there are, and we're going to talk about how to factor those. So before we get to how to factor, let's recall the signs. So when you're factoring trinomials, remember you're going to look for factors of the constant, which in this case for all of these scenarios would be c. So factors of c that add up to the middle term, so that add up to b in this case, since we're using b. So we want factors of c that add up to b. So if we have both positive signs, then I know that when I'm factoring, both my signs would be positive. If I have a positive and a negative, if I factor, then I know my signs have to be opposite. And because my middle term is positive, that means the larger number would be positive. Looking at the next one, if again I have opposite signs here, the only way to get a plus for the last term is if both of my signs were negative, because a negative times a negative gives you a positive, but if you add two negatives together, you get a larger negative number. And so if we have minus and minus, these are also going to be opposite. So this would be plus and minus. And since my middle term is negative, the larger number when we factor would have to be negative. So looking at this first one, number 1, the first thing we always look for is a greatest common factor. I don't see a greatest common factor, so that's when we're going to look for our factors. So we want factors of 20. So a little trick, you can use your calculator to help. So if I turn my calculator on, I'm going to go to my y equals just by hitting this y equals here. If I want factors of any number, I can just plug the number in and hit it divided by x. It's a lot easier than having to do guess and check on your calculator and just keep dividing. So then if you go to second graph, that gives you a table of your factors. Of course, the ones that are factors are the ones that are going to give you the whole numbers. So 1 and 20, 2 and 10. So factors of 20. Let's go ahead and write them out. Would be 1 and 20. 2 and 10, and 4 and 5. So again, you can see that from here. And you can know when to stop, because if you see 4 and 5 and then you see the opposite of that, 5 and 4, you know that you're just repeating those factors. So that's a good way to know to stop. So we want factors of 20 that add to that middle term. So in this case, that add to 9. And if we look, let's check our signs. Both these are positive, so I know that this is going to factor into two binomials, and both of them have to be positive. So what are factors that are going to add up to 9? 1 plus 20 is 21. 2 plus 10 gives me 12, and 4 plus 5 equals 9. So that tells me that my factors are 4 and 5. And remember, to factor the first term, which is x squared, that would be x times x, because if you FOIL this out, x times x, when you multiply something the same base, you add the exponents, that would give you your x squared. And it doesn't matter if you put a 4 here or a 5 here first, you can choose. So this would be my factorization, which again, if you wrote instead x plus 5 times x plus 4, that's the same thing, so it doesn't matter. But let's go ahead and check our work. So if I check, I can check by FOILing. So to check, x times x is x squared. X times 4 gives me plus 4x plus 5x. And our last terms, 5 times 4 is plus 20. Notice we have our like terms in the middle. So x squared plus, this gives me 9x plus 20. So notice that checks my answer. So we were correct in our factorization. These are easy to check your work by FOILing out. So if it's a test or a quiz, I always suggest doing so, because then that way at least you know that got the correct solution. So looking at the next one. So if we set up our two binomials, we have a no greatest common factor. So I probably could write that out. So no GCF. So since it's a trinomial, we are going to factor it into two binomials. Look at your signs. You have a plus and a minus. So the only way to get a plus and a minus would be if you have opposite signs. You know, one's positive, one is negatives. So let's go ahead and do our factors of 12. So you want to write multiples of 12 that add to 4. And again, if you don't know multiples of 12, go to your calculator. Go to the y equals and do 12 divided by x and go to your table. And you can see 1 and 12, 2 and 6, 3 and 4. Once they start to repeat, you know that you're done. So we have, again, 1 and 12. We have 2 and 6 and 3 and 4. So how do I know which one's going to be the positive and which one's going to be the negative? Well, looking here, notice that we have 4 is the positive as our middle term. So that means the larger number has to be positive and the smaller number is going to be negative. So that means this should be negative, this should be negative, and this should be negative. And if we add those together, we're looking for 4. So 12, if I subtract 1, or negative 1 plus 12, same thing, that gives me 11, so that doesn't work. 6 minus 2, or negative 2 plus 6, would give me 4, so I know that's my answer, but let's just keep going. Negative 3 and 4, if I add those together, I get 1. So that tells us that these are my factors. So we have x plus 6 times x minus 2. And of course, if you change around those binomials, you would still get the same answer, so that's okay too. So this is my solution. And of course, we could check our work by FOILing. X times x would give me x squared. X times negative 2 is minus 2x. Then we would have plus 6x minus 12. So x squared, and notice that this gives me a positive middle term, so plus 4x minus 12, and notice that checks out for my answer. So why don't you guys go ahead and do 3 on your own. So you do 3. Let's go ahead and look at 4. Looking at question number 4, same thing. We want to set up our factorization. So we know because both signs are positive, we know both signs are going to be positive here. We want factors of 45 that add up to 14. So in my calculator, I'm going to go to my y equals and do 45 divided by x. I'm looking for factors of 45 that add up to 14. So if I do this right here, 1 plus 45 is 46, so I know that doesn't work. If I keep going to the next one, I have 15 and 3, which of course is bigger than 14, so we know that doesn't work. So then I go down to 5 and 9. So when I see 5 and 9, I say, oh, well, that's equal to 14. So that's my answer. So x plus 5 and x plus 9. So 5 times 9 gives me 45, but when I add those together, I get 14. So hopefully you've done number 3 as well. Oh, and if you haven't, pause the video and do it, and then let's go ahead and check your work. So for this one, when we set up our two binomials, we know because both signs are negative that these have to be opposite. So we want factors of 30 that add up to negative 7. And if you want, you could put negative 30 in here instead of just positive 30. Divide that by x, and that will make the numbers, one of the numbers be positive and one be negative. You just have to remember that the larger number is negative. So if you went the other direction, if you wanted the smaller number to be negative, you go that way. So if I do this and keep scrolling down, we can see that none of those top numbers are going to work. So if we keep going right here, 10 and minus 3, so that would be our solution. So x, and it, because the middle term's positive, so we want that to be the 3, and this would be x minus 10. So that should have been your factorization for question number 3. And remember, the first thing you always want to do is look for greatest common factors. Just those first ones that we didn't have a greatest common factor. But if I look at question 5, now I would notice that I have 2, 8, and 8. These are all even numbers. So I know my greatest common factor is 2. So I'm going to divide out 2 by each number. So when I do, I get 2 times, and this gives me x squared minus 4x plus 4. And again, I see 3 terms, so that tells me I'm doing my factors of the last term that add up to the middle term. So when I factor my binomial sets, I have x here and here. I want factors of 4 that add up to negative 4. So factors of 4 are 1 and 4 and 2 and 2. And we know that since this is negative and this is positive, both my signs have to be negative. So negative 2 and negative 2 would be my answer. So you could write your answer like this. Or because you have 2 of them, you can write it as 2 times x minus 2 quantities squared. Either answer would work. Normally we write it the second way. So looking at question number 6, again, this problem, you have a greatest common factor. So that's what I would factor out first. And then after you factor out your greatest common factor, see if you can factor it further. So why don't you guys do this one on your own? That one's a little challenge one. So remember, take out the greatest common factor first, and then see if you can factor it further. So now we're going to look at factoring trinomials with the leading, when the leading coefficient is not 1. So we can do 2 different methods. We can either do factor by grouping or this new method that I call slide and divide. So the slide and divide method, I always say Swedish fish don't really swim, because this helps me remember the steps of what to do each time. So we're going to practice this first, and then I'll do the factor by grouping that you learned last year in Math 2. So S stands for slide, factor, divide, reduce, and swing. So if I'm using this slide and divide method here, well, first I notice it's 3 terms, so it's a trinomial. I notice there's a number in front and no GCF. So that tells me I'm going to use this method. So Swedish fish don't really swim. So the first step is to slide the number in front and multiply it by the last number. So 6 times negative 12 equals negative 72. I'm going to rewrite my new equation. So x squared minus x minus 72. F stands for factor. So now I want to factor the new equation. So when I'm factoring this, I know that this factors into two binomials. The first terms are x because x times x gives you x squared. You know your signs have to be opposite. So in my calculator, I'm going to go ahead and plug in 72 divided by x into my y equals, and then I'm going to go to second graph, which is the table, to look for the factors. Since my middle term is negative 1x, I know that my larger number has to be negative. So if I have 1 and negative 72, that's not going to add up to negative 1. 2 and negative 36 does not add to negative 1. 3 and negative 24 wouldn't either. 6 and 12. So if I keep going, I know I can stop right here because 8 and negative 9, if I add those together, would give me negative 1. So I have positive 8 and negative 9. So those are factors of 72 that add up to negative 1. So then the next step is, I know if I were to multiply this and FOIL it to check my work, it wouldn't give me 6x squared minus x minus 12. So if we took that term and multiplied it in the beginning, well, then you have to do the opposite and divide it back out. So when I divide it out, I'm always going to be dividing by the number I slid in the front, which was 6. So I divide both binomial term numbers by 6. R stands for reduce. So now we want to reduce the fractions. If you don't know how to reduce the fractions in your head, use your calculator. 8 divided by 6, I can hit the math fraction key, and that gives me 4/3. 9 divided by 6, if I hit the math fraction key, that gives me 3/2. So I know that this becomes x plus 4/3 and x minus 3/2. Then the last step is to swing any fractions that, when reduced, have a denominator. We're going to swing that denominator number to the front. So when I do that, I get 3x plus 4 times 2x minus 3. So this right here would be my answer to this factoring problem. And then I'm going to check my work. So to check my work, I'm going to FOIL. So 3x times 2x would give me 3 times 2 is 6, and x times x is x squared. So 6x squared. 3 times negative 3 is minus 9x. And then the inside terms, 4 times 2x gives me plus 8x, and 4 times negative 3 would be minus 12. And then I combine my like terms, 6x squared minus x minus 12. Notice that this is the same as our original problem, so that just checked my work. So you guys learned the method of doing factor by grouping. So I'm going to also show you how to do that. So instead, if I do factor by grouping, that's another method. It doesn't matter which one you use. So we have 6x squared minus x minus 12. Well, when you're doing factor by grouping, you do the same thing. You look for factors of 6 times negative 12, which is negative 72, that add up to the middle term, which we already said was positive 8 and negative 9. So this would be 6x squared, and we can do minus 9x plus 8x minus 12. It doesn't matter what order you put these middle terms in, it just means you're going to be doing a slightly different factoring. So when you do factor by grouping, you group the first two terms and the last two terms, and then remember you look for the greatest common factor. So between 6x squared and 9x, we know the greatest common factor is 3x. So then inside my parentheses, I would get 2x minus 3. And then for the second set, I can factor out 4. So plus 4 because it's positive. And inside my parentheses, I would get 2x minus 3. Because again, when you're taking out the greatest common factor, remember that means you're dividing it out. So then when we learned last year, when you do factor by grouping, you group the first two terms together. So you have 3x plus 4. And then you group the second terms together. And you can only do this if those terms are the same that I just highlighted. If they're not, then you can't do factor by grouping. So then this ends up giving us 2x minus 3. And notice this is the same answer that we got that when we just did the slide and divide factoring. So you can use whatever method you like, whatever one works better for you, that is fine. And so I want you to do, so you guys do this problem 8 on your own. So we're going to go ahead and factor number 9. Remember, the first thing you do is look for your greatest common factor, and I can see that each of these are even numbers. So I actually have a greatest common factor of 2. So remember, you always want to factor that out first. So remember, when you're factoring, that means you're dividing it out. So I'm going to go ahead and put the 2 in front. 6x squared divided by 2 gives me 3x squared. Negative 14x divided by 2 is minus 7x, and negative 12 divided by 2 is minus 6. And we're going to go ahead and practice our new factoring way, the slide and divide method. Swedish fish don't really swim. So remember, the S stands for take that first number and slide it by the last number. And the greatest common factor is just going to stay in front the whole time. So I'm just going to draw an arrow down and put it right here so I don't forget. So we have 3 times negative 6. When we multiply that, we get negative 18. So we have x squared minus 7x minus 18. Then the next step is the F, which stands for factor. So when we factor this, remember it's trinomial, so it factors into 2 binomial sets. The first term is just x and x, because x times x gives you x squared. We know the signs have to be opposite because you have a minus and a minus. If we go to our calculator, we can go to our y equals and plug in 18 divided by x, and then go to our table to find the factors that add up to negative 7. So because the middle term is negative, that means the larger number would be negative. So 1 minus 18, that's not going to give us negative 7. 2 minus 9 would give us negative 7. So we're going to use positive 2 and negative 9 for our factors. And then remember, the D stands for, if you took that number in front and multiplied it in the beginning, we have to divide it back out. So we're going to divide the 3 out because that was what we multiplied the 6 by. So when we divide that 3 out, we get then R, which is reduce our fractions. If they don't reduce, the number just swings in front. So that becomes 3x plus 2. And here, 9 negative divided by 3 gives us x minus 3. So this would be my factoring. And we can check our work by FOILing. So if we FOIL this out, 3x times x gives us 3x squared. 3 times negative 3 is minus 9x. And then inside terms, we get plus 2x, and 2 times negative 3 is minus 6. These are like terms, so we can combine those. So 2 times 3x squared minus 7x minus 6. And the last step would be to distribute the greatest common factor to each of those terms. And so when we do that, we end up with 2 times 3x squared gives us 6x squared. 2 times negative 7x gives us minus 14x, and 2 times negative 6 is negative 12. So notice that gives us our original equation back, so it checks our work. Now we can also do, remember, factor by grouping. So let's go ahead and do the factor by grouping method as well. For the factor by grouping method, so if I rewrite it with my greatest common factor in front, I have 2 times, and then remember it was 3x squared minus 7x minus 6. So for the factor by grouping, we know that the two factors are going to be minus 9 and plus 2. So 3x squared plus 2x minus 9x minus 6. Doesn't matter what order you write those in, you'll get the same answer in the end. Just you'll be factoring out different numbers. So remember, you group the first 2 terms and the last 2 terms and take out the greatest common factor for each binomial set. So 2, and then in my parentheses, for 3x squared plus 2x, my GCF would just be x, so that would go in front. And then inside the parentheses, I would have x plus 2, sorry, 3x plus 2. And then for the second set of parentheses, I can factor out a -3. So when I factor out -3 inside my parentheses, -9x divided by -3 would be positive 3x. -6 divided by -3 would give me +2, because remember, when you're factoring a term out, you're dividing it from each term. And so remember, as long as these are the same, you can group those two together, and then these numbers in front get grouped together when we're doing our factor by grouping. So this would be 2 and then parentheses x minus 3 times 3x plus 2. And notice that our answer that we got is the same answer that we got up here. The binomials are just in a different order, which doesn't matter. It's still the same answer. So you guys are going to go ahead for number 10 and complete that on your own. So look for a greatest common factor, and then you can either do this divide and divide method of factoring, or you can do factor by grouping.